And I think we can start with the first presentation. Welcome again to the technical session 1, which will be about EU fertilizing products regulation and REACH. Our first speaker is Theodora Nicolaou. I'm sorry, Theodora Nicolaou. I'm sorry, from European Commission DG Grow. And please, the floor is yours.
Yes. Hello. Good morning to all. Thank you for the invitation. I will try to very shortly present you the basic rules of the harmonized regulation on EU fertilizing products. Next slide, please. So it is about harmonized rules that apply on placing on the market of these products, of EU fertilizing products. This regulation does not regulate the use of these products, and it will be fully applicable as of July 2022. Under this scheme, the harmonization remains optional. This means that a manufacturer of a product may choose to follow these rules and place her product with a CE marking into the single market, or remain with his product following national legislation and able to put to place the fertilizing product under national rules. The basic approach is this of the new legislative framework approach, means that a product can bear the CE marking if it is compliant with specific rules, and to check this, the manufacturer needs to follow conformity assessment procedures, which are very explicitly mentioned in the regulation. There are cases where our regulation may cover fertilizing products that contain algae-based materials under specific conditions. I will give some more information in my presentation. And then for the first time, this new regulation will give end-of-waste status for materials that are recovered from waste if they are contained in a compliant EU fertilizing product. And of course, this regulation accepts only recovered from waste material if there are recovery operations explained, and if the conditions as set in the Article 6 of the Waste Framework Directive are met. Next slide, please. Just to point out that our regulation establishes basic requirements, specific requirements for safety, quality, and labeling of the products. It is important to highlight that there are specific definitions. I won't go into details. Specific definitions of the different products that may be compliant to our regulation. And just to give you an idea, algae-based materials may be part of, for instance, fertilizers, soil improvers, or plant biostimulants, according to the very specific requirements of this regulation. Next slide, please. So here I give you a table where I try to present the categories that materials may be part of, as this is described in our regulation. So you can have virgin materials, substances, and mixtures, but in this case, waste or waste origin materials cannot be included. Algae, for instance, extracts, could be the case, could be covered by this material. And then it is important to mention that these extracts should have a REACH registration dossier with a chemical safety report as fertilizing product also updated. There is a category to cover plant parts, plant extracts. And here it is explicitly mentioned that the algae, any kind of algae, are included, but this category excludes cyanobacteria. And of course, this category excludes any kind of chemical or heat treatment that might be applied in the algae to extract specific substances. Then we have categories that like compost or digestate that could allow input materials such as algae for the production. So in these categories, specific recovery operation rules are explained, mentioned, and additionally safety requirements are there. And through the application of Article 19, meaning the end of waste status, these categories, if the product is compliant to all the specific requirements of the regulation, and especially of this category, may be considered as non-waste anymore. It includes materials from algae. It includes algae themselves, but in one case, specific digestate excludes cyanobacteria again as input. Then there is a category for byproducts. This is still updated, so there are specific safety and efficiency criteria that will apply. For the moment, these additional criteria are studied by JRC, and there is a whole study ongoing. Probably, as this is based in a positive listing, probably this category won't cover algae-based material. And then we are under preparation of the adoption of three new categories, component material categories. Two of which, the one of thermal oxidation materials and pyrolysis gasifications materials, under very specific rules, may allow algae-based materials to be used as input materials for the production of materials that might end up in an EU fertilizing product. Next slide. And just to say thank you, this is a very technical regulation, and we are happy to discuss technical questions. You can always reach out to my unit, and we will get back with specific questions, specific answers if you have more questions. Thank you very much.
Thank you, Theodora. This is indeed a great introduction to the framework, regulatory aspects for this sector. So we move now to the second speech. The second speaker is Leon Fock from Eurofema.
Yes, good morning, everybody.
Good morning.
Thank you for your time. Representing European organic fertilizer manufacturers. And next slide, please. Just a few concerns on algae derived from waste in organic fertilizers. So we have, of course, the basic concerns, which are heavy metal contents and pathogens. But of more concern are the maximum residues, for example, residues from plant protection products and pharmaceuticals, and the limits set in the fertilizer product regulation of these residues. And the FPR has provisions on maximum residue levels, and they're especially linked to labeling requirements, but it does not explicitly define the intensity and scope of monitoring activities done at manufacturers of these types of input products. And this is something you might want to define more strict, especially if you derive algae from waste. Another concern is efficacy. Efficacy of algae in a fertilizer is disputed. Some member states prohibit claims based on the use of algae in fertilizers. And as said in the session before, we talk about the nutrients, but the levels are very low and the costs are very high. So currently, there are more marketing than efficacy if you look at products on the market. And the last concern is that a lot of people talk about the good carbon footprint and carbon recovery. But if you look at the necessary processing of algae to get them functioning in an organic fertilizer, organically based fertilizer, probably the processing does offset your carbon footprint gains. So all in all, nice products, but we have quite some concerns on maximum residues, on efficacy, and on the actually carbon footprint. That's my 3 minutes. Thank you.
Thank you. That's actually less than 3 minutes, so perfect. Thank you. So now we still keep the questions for the question and discussion after the end of this session. I see that there are many in the chat window again. This is very good. I would like to introduce our next speaker, Jose Maria Gomez from Biomass Peninsula.
Hello, good morning to everybody. Good morning. My presentation is about the 2 experiences into research and development project at European Union. So you can go to next slide, please. Just a short introduction of our company. We are a bio-waste recycling company based on Spain. So you can see the main activities we are performing and our participation in different European projects. So next slide, please. The first project was a live project. It was working on wastewater, tertiary wastewater, with the purpose of eliminating the phosphorus and nitrogen in the tertiary treatment. So it was made by biofilm technology. And going to the microalgae side, we obtained 2 types of final product, like liquid extracts. This seems like diluted microalgae, and the second was solid blends. First, we dry by lyophilization the microalgae and made solid fertilizers using microalgae as additive together with biochar and compost. So this is the two final products. Next slide, please. And the other project was a 2020 project, and the substrate was different, was the organic fraction of municipal solid waste. And in a side part of the project, a cultivation in raceway was developed, and the microalgae was used to clean the biogas from the anaerobic digestion. So its siloxanes and sulfite were eliminated, and microalgae were produced with the final target of producing a biostimulant from microalgae through enzymatic hydrolysis. Next slide, please. And going to the target of the webinar today, speaking about the legal aspects, some of them were already covered. And the conclusion about the legislation thing is that, of course, if we use waste substrate to grow microalgae or waste nutrients, this product from microalgae may not be eligible for component material category 1. Of course, I think the sign office question was still on the table, because it seems today that you cannot use the sign office not through any of the categories with the fertilizer regulation. So someone in the webinar can clarify this question. And of course, there is a harmonization work in progress, and the Commission made a mandate. The next slide, please. Made a mandate. 340. I don't remember the name exactly of the committee. Made a mandate to send committees to develop standards for microalgae-based products, and there are, of course, two technical committees that are working into microalgae standardization. Is the 454 on algae and algae products, and the 260 was fertilizers and alignment materials. Just to give you a conclusion of our experience through these projects, I can say that microalgae are a wonderful material for bio-based fertilizers. mainly not due to the nutrient content, to the nitrogen content, but to the functional properties. Selecting the species and the strain was very important to have the better results. So we did in this project a species selection and strain selection for the production. And what we found is, of course, you can do a very wonderful biostimulant with amino acids from microalgae, but we found in the first of the project, in the live project, that using the microalgae in natural state, like dilution, was the best result between all the solution we produce the final products. So I think this is more or less all from our, and now I'm ready to give you more information and to answer the questions. Thank you.
Thank you, Jose Maria. I see that there are already some questions for you in the chat window. Please,
I will try to answer. Yes,
you can answer later. So we have two more speakers in this session. The next one is Anyaescudero from Glasgow, Caledonian University.
Hi, hello, good morning. I'm shortly gonna talk about the experience gained as part of FOSS4U and the microalgae growth from municipal wastewater, the biomass, the microalgae biomass that we got, and some of the barriers we found in terms of its valorization. Next slide, please. So we tested a 500 liters photobioreactor from a Greenskill Environmental in the Wastewater Development Center in Bo'ness, managed by Scottish Water Horizons. And well, we work with an acidophilic microalgae, Chlamydomonas acidophila, which works at low pH. And we tested this microalgae for the treatment of primary sedimentation effluent for around 6 months. Next, please. Well, we got quite promising results, good recoveries, and even 50% of organic carbon removal from the effluent, because these species are also mixotrophic. So during these 6 months, it showed to be a very quite robust system, and it maintained monoalgal culture for the whole experiment. And well, because of this low pH, we also saw some advantages in terms of operation. So it was quite easy to separate the microalgae from the liquid using tangential flow filtration without showing any foam or biofilm formation in the photobioreactor. Next, please. So we had around 4 grams per liter of microalgae biomass in the reactor, and the increase in the pH of this effluent. We sedimented the biomass quite easily in about 5-10 minutes, getting a product of about 4 to 6% of total solids. We dried this product to get a microalgae powder. Next slide, please. So this powder was analyzed by our colleagues, quality assessment team, as part of the project FOSS4U. And well, these were the preliminary results they got. And in terms of contaminants, pathogens, and persistent organic pollutants that we tested, all of them are lower than the limits established by the legislation. In the case of the copper, if we actually see all the PFCs where this product might fit in, only in some of them, this limit might be problematic. Well, we are still testing this product to see the phosphorus availability through both trials and pharmaceutical and ecotoxicity tests. Next slide, please. So the way we see it, there are 2 potential CMCs where this product could fit in. CMC2, where it fits the requirements. And of course, to be able to fit in the CMC7, it might, we need to, this species should be added into the positive list. In terms of potential product function categories, these are the ones that, because of the characteristics of the product, that we could fit in as well. Of course, the microbial plant biostimulant could only be possible if, again, if this microalgae would be added in the positive list as a CMC7. And in terms of the liquid paste, let's say the algae paste that we get with 4 to 6% of total solid, it could only be under PFC3 if it would be authorized a liquid soil improver. Next slide, please. Yeah, thank you for your attention.
Thank you, Anya. And we have a lot of discussion in the chat window. I see a lot of it is about the inclusion of cyanobacteria in the positive list of the fertilizer regulation. I think we can maybe comment on that later, but now I would like to introduce the last speaker of this session, Frank Rogalla from Aquaria, Spain.
Yes, good morning.
Good morning.
I'm so happy to be here among all the experts on regulations. I will focus more on the technical aspects. We had the chance to work during 10 years on various ways to convert algae into value, all the way from Algae to Sabana. Obviously, we were based on a very simple idea. How can we avoid the energy use and the sludge production of conventional wastewater treatment? And we saw algae as a key factor that can directly treat wastewater. And the biggest advantage actually is the oxygen production. That is the biggest energy that you can get out of algae, is to replace conventional electricity for blowers, but use the algae oxygen to eliminate the contaminants of the wastewater. And actually the other factor is the symbiosis with bacteria that gets you CO2, so you don't need any artificial CO2 in the system. We feed directly on raw wastewater and then have a flotation to feed digesters, because the simplest way to convert biomass to energy is methane, digestion of biomass, anaerobic digestion for methane production. And then we actually use the raw wastewater to clean the methane and therefore recover the CO2 that we put back into the system. So it's a complete circular system to produce biomethane from algae based directly on raw wastewater. And then we have a side product, because obviously methanization is never complete. About 50% of the algae remain as potential fertilizer or other products. So that's something we have demonstrated now on a very large scale. 2 hectares worth, 4 ponds of 5,000 square meters, thanks to all the help we got from John Benneman, or from the University of Almeria, or from the University of Cadiz. And obviously the main focus was to optimize the algae cultivation and reduce the energy input so that the overall energy balance would be positive. And that's really the main thing, is that we try to reduce energy input as much as possible, and the algae there with the oxygen production is key. Then we harvest in a very efficient way with flotation, go directly to 4%, can feed directly in the digester, clean the biogas with raw influent to recover the CO2, and in the end meet the car standards. That was another thing of the All Gas project, to make sure we can meet vehicle standards for biomethane. And we've done it now many years, and we can show that it is a sustainable and carbon positive way to transform wastewater to biofuel, with a lot of different fleet vehicles that have been tested. And in a nutshell, on 1 hectare of algae, about a football field, you can treat about 1,000 cubic meter per day. That's about 5,000 people wastewater. And in the end, you can save the energy bill of about 20 households. So that would be all the players on the field get a free energy bill. And in addition, you can move 20 cars with the biomethane produced. Therefore, also all the players can drive home on a clean and green and free biofuel. Just that we have this leftover of 50 tons, half of the biomass that we can now use for fertilizer. And that is where Sabana works on right now, our new project with the University of Almeria, led by Gabriela Cien, where we built 2 more facilities here, similar to the one we already have in Chiclana near Cadiz, on a different geography here in a little further north, one in Extremadura in Merida, one in Jaén in Albacete, and those ponds are about to start. And we saw from Juliana from University of Milano, who's part of our team, that actually one of the nice things about wastewater algae treatment is the photo disinfection, because we normally use about 3 days detention time. Therefore, the wastewater sits in the sun for about 3 days. Also, the oxygen production is rather high. So we have photo-oxidation, both of the pathogens and of other micropollutants. And we, together with the University of Cadiz, we did an analysis on this photocatalytic effect, both on the pathogen destruction and the micropollutant removal. But obviously our focus now with Sabana is really the fertilizer treatment. And that's where we still have some work outstanding, other than saying, of course, that it is possible to get a very good fertilizer effect or stimulant effect. And of course, that's where we have to see how do we define our product and how does it best fit into the regulation. Thank you very much.
Thank you, Frank, and congratulations for showing this steady scale up of your project throughout the years. So this was the last presentation of this technical session. We have enough time for discussion and questions, but before that, I would like to take just 1 minute to explain a couple of things I didn't mention at the beginning. We have rapporteurs for these 2 technical sessions. For this one specifically, we have Marie-Edith Plotot from Lippe Verband Phosphor and Aurore Asake from the University of Ghent and the Biorefined Cluster. And we also have panelists, besides, in addition to the speakers, that are free to intervene in the discussion. Peter de Jong from Vetsus and Water Europe, Rita Araujo from European Commission Joint Research Center on Sustainable Resources, Roberta Congestri from the University of Rome and the Italian Association for the Study and Application of Microalgae, and John Benneman, Microbioengineering and Algae Biomass Association, which you have already met before. Apologies for not introducing them before. That being said, I would like to open the discussion to the speakers and the panelists. I see Peter already raising his hands, and maybe Chris, you can help us to convey to the speakers and the panelists the main questions from the chat window. Peter, please go ahead.
Yeah, I've got already one question that was addressed towards Theodora. The question was from a regulatory perspective. Does it matter whether processed algae is land applied or a harvested culture, between brackets not processed, and the spray is irrigated?
Depending on, I guess this goes for whether it is covered under a CMC too, because there are no specific restrictions on how this algae based material was grown. But I don't know if I get the question right.
Maybe Chris wants to elaborate on that. Now, the question was raised by somebody else, so I do not have additional info for you. So I'm conveying a question from other people. Thank you.
Yes, maybe in the questions, there were a number of questions about cyanobacteria and their definition. Is there a standard definition of cyanobacteria as to which are excluded and no? So that refers to sort of industry standard definition, or?
There is no explicit definition on this. I mean, a generic taxonomy, microbial taxonomy might be used. And then I see, and it's an upcoming question, I mean, I see that the paradox is there, that some cyanobacteria are good enough safe enough to produce food, and then they are excluded. So we keep receiving these questions, and it might be a good idea to look into these specific materials in the future. And this is something that we do. We're not really investigating at this time, but we have the empowerment. The Commission services may amend the technical requirements of FPR according to technical progress. So if we have enough information, technical supporting evidence, then we could definitely amend. If it will be the case, I don't know.
Okay, so that is a clear call to industry to provide. Spirulina was the species cited, but to provide evidence, firstly, that there is actually a market and an interest to use it in fertilizers, and secondly, to provide evidence that it is safe.
Good. Are there any panelists willing to intervene? Not for the moment.
This is John Bellerman, and I would like to say that, this is rather shocking that cyanobacteria are excluded as a category when people all over the world eat many thousands of tons of spirulina. It is used as a biofertilizer or biostimulant already fairly, not widely, but at least it is used by many. So I think that the European Commission should not ask for people to show the safety, but they should show why they excluded something that is consumed by people all over the world, including in Europe, of course. It is rather strange. So I think that the European Commission or regulatory agencies should be proactive, not wait for the industry to tell them.
Thank you, John, for this statement.
May I just add just a statement on this cyanobacteria solution? EABA is establishing working groups on biostimulants, and Gabriele Sien is leading this. So perhaps whenever this discussion is open, Gabriele is the first person to consult on actual market and usability of cyanobacteria in agricultural uses like fertilizer or biostimulants. So I would definitely support change in this topic. On the other hand, of course, for any algal culture, we cannot guarantee that there is no cyanobacteria. Anything that is grown in sufficiently large scale contains certain proportion of cyanobacteria for sure, and they are more dangerous than those that are grown on purpose. Thank you.
Thank you, Robert.
There was another question which was about the status of algae or materials recovered from algae which are grown in waste streams, such as sewage or wastewater from aquaculture. Are these considered to be waste-derived and therefore excluded under CMC1? Or can such algae and materials processed from them be included in CMC1 in the fertilizing products regulation?
So, Theodora?
Yes, but the regulation does not define anything on the waste status of the material. So everything should be cleared first from the regulatory aspect of the end of the Waste Framework Directive. And then it's clear that the national legislation puts all the specific requirements. Whether the material is waste in a country, I cannot tell. I'm sure that in national legislation, it would be identified as waste or non-waste. if it's waste, it cannot cover it by CMC1. This is clear.
Okay, so in fact, it's up to the producer to obtain a clear waste or product status from their national regulator.
Yes.
Did you consider that national regulation or national implementation of end of waste directive is widely different? So national practices are very, very different in different parts of Europe. And I would like to see this unified fertilizer directive to slightly ignore the national idiosyncrasies that are present there. That is not the fact as far as I understand.
Yeah, it's not a fact for every material. That was the case for compost and digestate under very specific criteria with very explicit recovery rules that of course may leave some of the materials, safe materials out of this legal framework, but the attempt was only indeed for the compost and digestate and not for all categories.
Yes, and maybe just to comment, that was based on the fact that there had been a long EU study by the Commission, by JRC, yes, on end of waste status for compost and digestate.
Yeah, correct, thank you.
But maybe for algae, a question is, are there standards which could be used as input to that discussion to either facilitate member states arriving at the same conclusion, or possibly in the long term adding an algae CMC into the fertilizing products regulation? But that may not be the best approach because it would only resolve fertilizing products and not feed and other things. Are there quality standards for algae from different waste-derived materials which can be used, or is that under development? Does anybody know? Anya, we
Chris,
can't hear you.
Maybe quickly comment on that. As far as I know, there are no standards with respect to fertilizers and algae. Besides the standards we use for determining an N or a P, of course, so determining nutrients. And a little bit broader on the discussion, we could try to add CMCs for algae or do all kinds of difficult stuff. But is there a business case in the agricultural market to make these efforts? And I think that there is a big question mark how good that business case will be in our market.
Yes, and I see that a lot in the chat. There's a lot of more interest maybe in using algae in animal feed where the value may be higher. And indeed, it's higher up the waste hierarchy. Anya, do you wish to speak?
Yeah, just a few comments or thoughts. I mean, in our case, we are working quite in a small scale wastewater treatment plant. So, yeah, that getting a bit of an easy, not too complicated product, which doesn't cost that much money to actually process it, etc. So the market is a bit limited. But also, I think that the fact that there are not that many, in terms of the CMCs and in terms of the PFCs, there is a bit of confusion as I show in the slides. There are not that many CMCs where we could fit our product. Plus, there are a few PFCs where it fits, but the limits, for example, in terms of heavy metals or other pathogens, and they differ. So it is a bit confusing where we can fit our product in order to be able to use it safely.
Thank you.
Yeah, that was just a comment. I don't think it was a...
Thank you. I think maybe Robert wanting to intervene again. You are muted, Robert.
Sorry. Yes. Well, not really particularly. EABA is participating in the standardization effort, and we are not there. I mean, to really establish food safety. Maybe on food safety we are close, but on for example, fertilizer safety, it's not even considered yet. But I think this effort needs to be done. And about the business case for microalgal agricultural products, the story goes very simply. Until there are no products being tried, the market doesn't accept. This is the situation that used to be here 20 years ago for macroalgal products, which have now become very fashionable in the for agricultural use. And there are a few products already existing that cyanobacterial, to be honest, spirulina-based products that are used in agriculture, and they prove there is an emerging market for that. So we all tried to copy the macroalgal path that proved to be successful with microalgae that are coming from different waste streams and that have otherwise relatively low value. So we need to develop value for that. And it's ongoing process.
Thank you, Robert. I think we have an interesting question, a general question to all the speakers. If we can explain a bit more in detail what the acronym of CMC stands for. Or can anyone explain what CMC is? Thank you.
I think I also included in my presentation, so if you go back, you will find everything. PFC stands for Product Function Category. So this annex describes all the categories of products according to their functions, either a fertilizer, a biostimulant, and so on. And then the CMCs are component material categories, meaning in short, the materials that may be allowed to be present in the final composition of a product. So again, there are categories with specific requirements, technical specifications, covering materials. So your material has to be covered by a CMC. And if everything is fine, then you have to check the function of your product, if it's functioned by a PFC and the requirements. And then of course, you have to comply with the labeling requirements. And then you can, if everything is compliant, then you can, and you have an EU declaration of conformity, you can affix the CE marking on your product.
Thank you, Theodora, for this clarification. We have any panelists wishing to speak, or Chris, do you think we have other questions? Otherwise, we are quite on time with the agenda, and we might have some time for a larger break. Not too much, but the second session we start at 11:15. So we would have enough time to take a break, and let's meet again at 11:15. And maybe if we keep with the timing of the agenda, we can have a shorter break after and conclude a bit earlier. Let's see how it goes.